Geometry in 12.6, we're dealing with surface area and volume of spheres. There is no lateral area in a sphere because there's no straight edges. And depending on your book, depends on what they call lateral area. Now in this book, we talk about lateral area being of straight edges, okay? The edges around a figure. And since a sphere is a complete circle, one piece, then it has no lateral area. It's just surface area. And what we call the surface area, and the formula for surface area of a sphere is 4 times pi, and don't use 3.14 unless told. So 4 times pi times the radius squared. The radius is from the center of the circle to an edge of the circle. Okay, now you notice there's some pictures here. There's a plane intersecting the sphere at one point. It intersects it in the circle, okay, but it's not in the center of the circle. So it just makes a circle with a cut into your picture. And then, of course, there's a great circle. If a plane is intersected the circle exactly in the center of the circle, of the sphere. Okay, so hemisphere is half of the sphere. Okay, hemisphere is half of the sphere. The area of a hemisphere is the area of a sphere times 1/2. And then you've got to add the circle, the top part of your sphere. Okay, and remember, a sphere is cut in half. Okay, so pretend that that's the best I can do, I'm sorry. But your sphere is cut in half. It's got the area of the sphere, which is half of it, like it normally would be, plus the area that is on top, that circle area. All right, so it's 1/2, 4 times pi times the radius squared, and then you add the area of a great circle. But the area of the great circle is just an area of the circle, pi r squared. So you've got 1/2 times 4 times pi r squared plus pi r squared. Okay, now you can combine those, you can do other things, but that's the general gist. All right, if you want to use it shorthand, okay, this is fine, pi r squared. But if you'd like to shorten it, half of 4 is 2 pi r squared plus pi r squared. You notice that pi r squared and pi r squared are the same. Coefficients in front of it are 2, and there's a 1 here, you just don't see it. So you really get 3 pi r squared. That's the shorthand of the area of a hemisphere, but this top one is just fine to use. Okay, the bottom one is fine too. The great circle is just the area of a circle, pi r squared. It's the top of a hemisphere. The volume of a sphere is always 4 divided by 3 times pi times the radius to the 3rd power. Okay? To the 3rd power. That's what that little caret means, is raised to the 3rd power. And of course, volume of the hemisphere is half of that. So 2/3 pi r cubed. Half of the sphere. If you find the volume of the sphere, divide by 2, you get the area, or the volume of the hemisphere. So example 1, find the surface area of a ball with a circumference of 24 inches to determine how much leather is needed to make the ball. Now remember, surface area is 4 pi r squared. But we're not given the radius, we're given the circumference. And if you recall, circumference is 2 times pi times r. 2 times pi times r. So the circumference is 24 equals 2 times pi times r. All right, and we want to solve for r. So we just divide both sides by 2 pi. If you divide by 2 pi here, they cancel out. If you divide by 2 pi here, you get a number. Now make sure that it's in parentheses when you divide by it in your calculator. All right, so we're going to do that. We're going to do 24 divided by 2. All right, so I'm going to show you how to use this with your graphing calculator. And you've got 2 4 divided by parentheses 2, and I'm going to use the pi button, so second caret, close my parentheses, and then I'm going to hit enter. And I get 3.8197, okay, or 12 divided by pi, either way. I'm actually going to use that over here so it looks prettier. All right, so now that I find r is going to be equal to that amount. That's your radius. Now that I have my radius, I can substitute it into the area formula, which I think is on the next slide. So remember, r is this amount. Over here to the side. And we substitute it into the formula. We've got 4 times pi times r squared. And I don't want to round until very, very late. Okay, I'm going to put that all into my calculator. And I'm going to show you how to type that in. You've got 4. You've got pi. And you've got that number. So I'm going to set second answer squared. And I'm going to hit enter. So I get about 183.34 3464. Okay, and then we want to round it. So let's go back and look at how much we want to round it by. Okay, since we're looking to see how much material to use, you always want to round it up. So instead of 183.3, even though it's not 5 or greater, it's material that we need. So approximately 184 inches squared, or squared inches, that you need for the material for the covering of the ball. All right, so in example 2a, we want to find the volume of the sphere, and we want to round to the nearest tenth. Well, the radius is given to us from the center of the circle to an edge of the circle. That's your radius. And we just put it into the formula. V equals 4/3 pi 15 cubed. And remember, to get your full amount of points, you want to show your work, even if it's as simple as that. You use the calculator for the rest, you wrote out the formula, you will get your points. All right, and it has to be with the correct information in it. So here's my work. Okay. We only need this bottom portion right here. All right. We hit enter, and we get 14,137.166. So the volume equals 14,137. We're rounded to the nearest tenth. So here's your tenth. Now look one past it. Is it 5 or greater? And it is. So it's 0.2. We're talking about centimeters. So centimeters, and it's always, volume is always cubed. If you don't put the correct units, I will count off on the test. So make sure you've got those correct units. All right, so 2b, we have the circumference equals 25. Same thing as what we did before, we're finding the radius. You've got to substitute in 25 for your circumference and divide by 2 pi. All right, the reason we divide by 2 pi is because we want to cancel out the 2 pi that's beside the r. And they cancel out. Whatever you do to one side, you've got to do to the other. Again, remember that if you put that in your calculator, 2 pi has to be inside the parentheses, otherwise your calculator reads it incorrectly. So, 25 divided by parentheses 2 divided by 5, excuse me, not pi, 5, 2 times pi, close your parentheses and hit enter. And that's what you get for your radius. 25 divided by 2 pi is approximately 3.97888. Again, you don't want to round too early on your radius because you're going to have to use that in order to find the sphere. All right, so now we're going to use the 4/3 pi r squared. And we're going to substitute in the radius. Now, I'm going to round on the board, but I'm going to keep the radius in my calculator. So 4/3 times pi times, now we said that the radius was like 3.97. Okay? But again, when I'm going to use my calculator, I'm going to use 4 divided by 3 times pi. And if you're in doubt, always put your fractions into parentheses. This is okay, but if you're in doubt, you can always add parentheses around your fractions, and it will read it correctly. Times, and I'm going to put the second answer, the second little negative key, to pull up the 3.978873577 so that it reads it correctly. And then I'm going to hit raised to the 3rd power, which I didn't write over here, but that's what it is. It's raised to the 3rd power. And then I hit enter. Okay, now that I've got it, I'm going to pull it out over here. And that is my volume, 263.8572. Now, the question is, go back to the beginning, and it said round it to the nearest tenth. So rounding that to the nearest tenth is like before. You look at the tenth place, the first place behind the decimal. Then you look at the one behind it. Is it 5 or greater? And it is. So your volume is going to turn out to be 263.9 centimeters cubed. Volume is always cubed. And you get your answer. Again, just show the work that's above it. It's not that bad. You're showing your work. I can see if you missed this problem, why you missed the problem. And we can go from there. On this one, compare the volume to the sphere and a cylinder with the same radius, height, and radius of the sphere. All right, so volumes, we need to make sure that we know the volumes of a sphere and a cylinder. So on this next page, we have the volume of the sphere, which is 4/3 pi radius cubed. All right, 4/3 pi radius cubed. And the volume of the cylinder is pi radius squared times h. Now, if you go back to the picture, the height of your cylinder and the radius are the same amount. Okay, that only works if that's the case. So because the height is r, I get this formula. All right, now remember, if you have x times x times x, you really get x to the 3rd power. Well, I have r squared, which is r times r, and then I'm multiplying r again, so I get r to the 3rd power. So a cylinder with the height of r and the radius of r is pi r cubed. A sphere that has a radius of r to the 3rd times pi to the 4/3. All right, so these are your two formulas that you're comparing, the sphere and specifically in this case, the cylinder. What's the difference between those two formulas? 4/3 pi r to the 3rd and pi r to the 3rd. Okay, so the sphere is multiplied by 4/3. Now my question is, which one's bigger, the sphere or the cylinder? 4/3. Is it a number bigger than 1 or smaller than 1? Because there's a 1 in front of this pi r to the 3rd, even though we don't see it. Okay. So is this number, is 4/3 bigger than 1 or smaller than 1? Okay, 4/3 is bigger. Okay, so that means that the sphere is bigger by how much? Or larger. By 4/3. It's kind of neat. All right, your homework.